Hi guys, Steve Blankard here. Hey, I'm working on a Ford Powerhouse generator for Model A, from 1927 up through sometime in early 29, and I'm getting just starting to do restoration on this, and I've got the armature set up here in a growler, so I thought I'd show you a little bit about how I test an armature for a Powerhouse generator. Just a quick look. This is what I'm working on right now. I just started taking this apart about an hour ago, and it's pretty greasy and grimy, but it'll all be restored. The field coils will come out and get new field coils, new sealed bearings, brushes, wiring, etc. So it'll all be just about as good as new when I get done. Here's an example of some other field coils I've taken out of other Powerhouse generators. Yep, there's 6 field coils in a Powerhouse, so yeah, they're pretty complicated generators. So let me get this set back up here, and I'll show you what I'm doing. Hopefully you can see this okay. So on an armature, I do 3 tests on an armature. I do a short test first, which is what you're probably most familiar with. That's using a hacksaw to look and see if there's a short in it. It'll magnetize the laminations, and the blade will vibrate on it. The second test I do is a open test. That's where I'm going to measure output voltage on adjoining pairs of commutator bars all the way around. And then the third test is going to be a ground test, where I want to make sure that the commutator is not grounded to the frame. So first off, get ready to turn this on. It makes kind of a loud noise. That's why it's called a growler. It sounds like it's growling. And I'm going to rotate the armature 360 degrees while I've got the blade around the perimeter of it, just to see if there's any vibration or if it gets magnetized. So here we go. Then I put it on here. It's not magnetized. Right, so I'm just going to start rotating it around. And so far, so good. Nothing. All right, that's 360 degrees. Turn it off. Okay, so no, was not magnetized. It got no vibration off it, so it passed the short test. So the next thing I'm going to do is test for opens in the winding. So what I'm going to do is I have 2 probes over here, and I've got this little rig made up from an old power cord with the 2 prongs bent together, so I can touch 2 adjacent commutator bars. And what I'm going to do is I'm looking on the voltmeter here for 1 or 2 volts on each pair of commutator bars as I rotate it around. And if I see voltage on each pair, that tells me that each pair of the windings is producing voltage. If I have an open one, it means that the generator would still work, but its output is going to be reduced. So I'm going to put it over here on low volts, touch it up to adjacent bars here, and you see I'm getting, it's kind of hard to see here, but I'm getting about 1 to 2 volts there. I'll rotate a little bit, do the next set, there's 2 volts, next set, 2 volts, next set, 2 volts, and I would do this all the way around, rotate the armature a full 360 degrees, so I check each pair. So I'm not going to do all of them now for the demonstration, but that by checking the output of each adjacent pair of commutator bars, that tells me that the armature, each segment, is producing voltage. Now the third test is the ground test. So I'm going to disconnect my little jumper here, and I got 2 probes, so I want to see, make sure that the commutator is not grounded to the frame, and the frame is connected to the lamination. So I put it at the ground position. If I put the probes together, a red light comes on. That just tells me there's a continuity there. So I want to check, like from the frame to the laminations, I get a red light because that's all electrically the same. But what I want to see is that I don't get an indication on the commutator. So I'll walk it around the commutator. If the light came on, that would tell me that the commutator is grounded. Do this set over on this side, and the light does not come on. So that tells me it passed the ground test. So this armature has passed all 3 tests, the short test, the open test, and the ground test. So that tells me that this armature is probably good. And I say probably because there's a kind of an old say in the generator motor world that a growler will definitely tell you if an armature is bad. It'll tell you if it is probably good, and that's because you can pass all these tests, and there's still a phenomenon where it may not work when it's running, and that's generally known as what's called a flying short. And what happens is when this is spinning in the generator, say at 2,000 RPM, there's a lot of centrifugal force here, and the wires can shift around and a little bit. And if the insulation is broken down on the wiring under that centrifugal force trying to throw them out, they could short together or ground. And if that happens, that'll kill the output of the generator. It's pretty rare. Most of the time, I know it passes all the growler tests. Most of the time, they're good. But I have seen a few where they will pass the growler test, but they get a flying short and they just don't work on the test bench. So it does happen. But odds are this is going to be good. I still have service to do on this. I'm going to put it in the lathe and recut the commutator here so it's level and smooth and polish it. I'll clean it up and then I'll coat the windings with clipped oil and then it'll be ready to use. So anyway, just wanted to show you a quick overview of how I do test an armature for a Ford Powerhouse generator. Hope you found this interesting. If you enjoyed it, please like the video and subscribe to my channel. And hopefully I'll have some more videos coming out soon. Thanks. Bye.